In this video, we are going to learn about the EDTA method of estimation of hardness. Okay, hardness of a sample, water sample. Okay, the term actually EDTA refers to ethylene diamine tetraacetic acid. Okay, this is a very important component or compound to be remembered. Okay, this is the structure of EDTA. Okay, so now what is the basic principle behind this estimation technique? So the amount of hardness is actually found out by titrating the water sample against EDTA using adiochrome black tea indicator, which is in short referred to as EBT. And the condition is that the pH should be between 8 to 10. So in order to maintain this pH, we add a buffer. And that buffer is usually a mixture of ammonium chloride and ammonium hydroxide. See, these are all important conditions to be remembered, right? So we use the indicator EBT, we use a buffer solution on to maintain the pH. Okay. Now, what happens actually? This is the next question. When we add EBT to the water sample, usually what happens is this adiochrome black tea indicator tries to form a weak complex with the calcium and magnesium ions which are present in the water sample, because it's going to be a hard water, right? We are trying to find out the hardness of the water sample. Okay, and this weak complex, okay, is usually wine red color, right? So that is what is given in the form of an equation here. So in order to form this complex, you will have to have a pH of 8 to 10, for which we use this buffer. Can you see this? Right, so EBT is trying to form a complex with the calcium and magnesium ions which are present in the sample at a pH of 8 to 10. It's a weak complex and its color is wine red. Right. Now we'll move on to the next part, where when the same solution, so now earlier we were talking about, see, imagine a conical flask. So it had the water sample and it had your indicator too. So it was wine red in color. So my indicator plus my water, together it was wine red in color. Now I am titrating it against a burette solution. The burette solution is nothing but EDTA. The moment EDTA starts falling into this conical flask, what happens when it's titrated? EDTA tries to form a stable complex with the calcium and magnesium ions. Okay, the calcium and magnesium ions which were earlier with the EBT will be now released. Can you see this? In this case, EBT is released. Instead, EDTA comes and occupies the place. Okay. So now what happens is, slowly what happens, the EBT which is in this complex will start getting released, and finally when all the EBT is released, or in other words, when all the calcium and magnesium ions form complex with the EDTA, at that moment the color of EBT changes to steel blue, which is the end point, right? So that is what is given here. So it releases the indicator and steel blue color, which is the end point. Okay. The color of free EBT, adiochrome black tea, is steel blue color, right? So that is the end point. Now we'll come in. This is the basic principle. Okay. So the complex, ultimately it is a complex formed by EDTA with the calcium and magnesium ions. Okay. In the presence of a buffer solution and adiochrome black tea indicator. Right. So now we'll move on to the procedure. The procedure consists of 3 different steps. First one is standardization of EDTA. First, what you do is, I use the word standard, which means whose concentration is already known. I take standard hot water. I take a known volume of that, and with the buffer and EBT, I'm titrating it against EDTA, and I'm taking the volume as V1. Okay. This is for standard. This is for standard hard water. Okay. The next one is estimation of total hardness of water. Now I am going to take the sample. Okay, earlier what I had taken was standard. Now I am taking the sample. I take a known volume of the sample and I am going to titrate it against EDTA in the presence of buffer and ABT, and I am assuming the volume as V2. Now if I have to find out this is a total hardness. Okay, now if I have to take the permanent hardness alone, the temporary hardness can be removed by boiling. So I'm boiling the water sample for 15 minutes, I'm cooling it and I'm filtering it. So my temporary hardness will be removed now. Okay, now that particular water sample, which I call it as B, I take 50 ml of the sample and I'm titrating it against EDTA in the presence of buffer and ABT, and which I take it as V3 ml. Okay, now in the case of calculation, just one part of the calculation, if you are able to understand, the rest others is the same. Okay, so 1 ml of standard hard water, standard I told you, we already know the concentration, which is 1 mg of calcium chloride and 1 ml of standard hard water. So if 1 ml contains 1 mg, then 50 ml of standard hard water will have 50 mg. Now we already saw that in the first titration where we used the standard hard water, we took 50 ml, you remember? So 50 ml of the standard hard water actually consumes V1 ml of EDTA, which means okay, so V1 ml of EDTA consists of 50 milligram is equal to 50 milligram of calcium carbonate equivalent hardness, right? So because we have used calcium carbonate as the standard, and usually we represent our hardness as calcium carbonate equivalent. So if V1 ml is equal to 50 mg, then 1 ml of EDTA is equal to how much? This will be your base for remaining calculation. So now we are trying to find out the total hardness of the sample. We took 50 ml of the hard water sample and we found out that that is equivalent to V2 ml of EDTA. Just keep this in mind, how much ever we complex titrations we do, the basic for calculation will always be V1 N1 is equal to V2 N2. This will never change. So however hard a titration may be, however complex it may be, this is the basis for the calculation. Okay, so now this 50 ml of, we already told 1 ml of EDTA is equal to 50 by V1 milligram of calcium carbonate equivalent hardness. We already told that. So now we know that since 1 ml of EDTA is equal to so much, so we are trying to find out now V2 ml of EDTA it is consumed, right? So we are trying to find out 50 ml of hard water sample is equal to how much milligram of calcium carbonate equivalent. So instead of V2 ml of EDTA, I am trying to express it in terms of calcium carbonate equivalent. So I have used this 1 ml is equal to so much. So V2 ml is equal to V2 into 50 by V1. Okay. So since we are going to express it in ppm, we require the amount in 1000 ml, right? Because we know parts per million is so many parts in million parts. So 1000 ml of hard water sample contains how much amount? So in this case it was for 50 ml. So I'm trying to find out for 1000 ml, and this is the calculation, right? So this is the final total hardness. Similarly, we can calculate for the permanent hardness of the sample, where we already knew that the volume consumed is V3 ml and 1 ml of EDTA is equivalent to how much milligram. So it's 50 by V1 milligram. So V3 ml of EDTA is equivalent to how much? So similar calculation, and we have found out what is the permanent hardness, right? So for finding out the temporary hardness, total hardness minus permanent hardness will give you the temporary hardness, so which is equivalent to this. The entire calculation is simple if you just understand only one step, the first step alone, okay, where we are trying to find out. See, if you understand this part alone, you are actually repeating the same thing again and again. right? So just understand this alone. So I have my entire calculation is based on only this line. Only this line. 1 ml of EDTA is equivalent to how much milligram of calcium carbonate equivalent hardness. Only based on that my entire calculation lies. Clear? I hope it should be clear by now. Thank you.